Okay, virtual students, if you can find your CFS lab packet, this is data that you wrote in and you have figured out your averages here. Average time, add these three up and divide by 3 gets your average time. Take your 50 feet divided by your average time and that gets you your velocity. We'll use that information later. Then you also have this data and we're going to graph the width in feet with the depth in feet. And so I took somebody else's sample data. Here we go. And if I divide 3 divided by 12, that gets me 0.25 feet. If I take 5 divided by 12, that gives me 0.416 feet. 8 divided by 12 gives me 0.66. It's these feet depths, depths in feet, I should say, that we're going to then graph. So we've got stream width and stream depth in a foot. On your graph paper that you have, here's depth in feet. I never went below 2 feet for this Maple Creek stretch. And there's my width in feet. So if I go over at 4 feet wide, we went down 0.25 feet deep. And then at 6 feet down, again, I'm looking at this data here, at 6 feet down, or 6 feet over, we were at 0.416. At 8 feet over, we were at 0.66. At 10 feet over, we were at an even foot deep. So you can kind of compare that. At 10 feet over, I went exactly 1 foot down. Then when I connect all those dots along the bottom, that's the stream profile. 0 feet straight across. If I draw a line across straight at 0, then that's my surface of the water. I then colored in all the blue squares so that I could count each of the blue squares. When you count those, that's square feet. And in your packet, on the second page, I believe, this is also where it describes how to do this stream profile that I'm talking about right here, so you could read that through there as well. But then you count all these squares, or count the blue squares that I had on my graph, and you'll put that number in there. If you were working with a team, you'd have a bunch of students in a team getting an average for your square feet. And when you count how many square feet you have, or how many square feet you have from your data table or your graph there, you're going to put that number right here. At Darts Park, what was the average square feet that you had? How many blue squares? Then you multiply times your velocity that you got from your other sheet right here, velocity. And if you multiply your squares, your square feet, times your velocity, that gives you your cubic feet per second. Then multiply by 7.5 to get your gallons per second, times 60 to get gallons per minute, times 60 to get gallons per hour, times 24 to get gallons a day. You should come up with data for Darts Park and Mineral Springs, Maple Creek, because that's the data that we collected. Then try to answer as many questions here as you can, but I think a lot of these are going to require all of the locations, so we'll see what we can get done.